Okay, lesson 92, uniform motion problems about equal distances. I have to be honest, this is probably one of my hardest lessons to teach. It's actually kind of fun, but until you get it, there's so many new concepts that this might be really tricky. So if you're still struggling with this, when we do it on when you do it on Wednesday, we can do some more of these in class on Thursday. When I read this first problem, you're going to understand the difficulty here. It says, on Tuesday, the express train made the trip in 12 hours. On Wednesday, the freight train made the same trip in 16 hours. Find the rate of each train if the rate of the freight train is 15 kilometers less than the rate of the express train. Now, first thing we're going to notice is these are called equal distance problems. All of these problems are equal distance. We're going to have a distance that both of these trains are going to go, and it's going to be the same. We're going to have an express train that's going to travel this distance. Here it goes, express train. So we'll call that this distance E for express train. It's going to make it in 12 hours. And then on the next day, a freight train. There's our freight train. It's going to do the same distance. You can see the distance is the same. From here to here is our distance. And this is our freight train. So the distance of the express train is equal to the distance of the freight train. A couple things to keep in mind. A very important equation, first of all, is distance is equal to rate times time. This has to be something that you memorize, inside and out, because we're going to have so many distance problems in Algebra 2 that you're going to go crazy. All the distances aren't going to be equal. These are equal distance problems. So the equation is distance equals rate times time. That's the main thing you have to know. And in these problems, distance 1 of whatever we do first is always going to be equal to distance 2. Alright, with these two pieces of information, let's see what we can do. Let's see what's going to go. Okay, here we go. We're going to write down everything that we know. I just wrote that in the part where I need some space. Let me write this really important formula over here. Distance equals rate times time. And we're going to know the distance of whatever we're doing in 1 equals distance of whatever we're doing in 2. So here we go. Let's write down the things that we know. First of all, you always draw this diagram. I don't care how silly you think it is, draw the diagram. And then we're going to write the things that we need to know is we know the distances are equal, but we need to know the rate for the time in order to find the rate or the time. So let's just write what we know. It says, on Tuesday, the express train made the trip in 12 hours. 12 hours, is that a rate or is that a time? Well, a rate would be something like miles per hour or kilometers per hour. That would be your rate. So this is our time. This is our time of our express train. So I'm going to use the subscripted variable time of express train is 12 hours. And I'm actually going to write this right here. Time of our express train equals 12 hours. Just start writing in anything you know, and hopefully we can make sense of all this. On Wednesday, the freight train made the trip in 16 hours. So the time of the freight train, we'll use all subscripted variables for these, equals 16 hours. We are to find the rate of each train if the rate of the freight train was 15 less than the rate of the express train. So we're going to set the rates equal to each other. The rate of each train. So the rate, there we go, we're going to do another subscripted variable. These are like the equations. Remember where we had 4 equations and we had to solve it? We had 4 unknowns and 4 equations. This is exactly what we're going to do here. So we have this equation, this equation. We know that the rate of the freight train, was less than the rate of the express train. There's 2 different ways you can do this. I don't want to confuse you. The rate of the freight train was 15 less than the express train. So this one's going to be faster, right? So we can either do the freight train equals the rate of the express train plus 15, or we could do, whoops, maybe I got that wrong. The rate of the freight train is the express train minus 15. Remember, we have to keep these balanced. This one's going to be faster, or we could say the rate of the express train is going to be the rate of the freight train plus 15. We have to keep our equations balanced. With the express train, the rate is going to be faster, so we have to add 15 on to the freight train. So let's just stick with this one. So the rate of each train, the rate of the was, let's see, the rate of, where is it at? The rate of the freight train was 15 less than the rate of the express. The express train is the rate of the freight train plus 15. This is kind of tricky. Okay, so now we have our 1, 2, 3, and here's another tricky part. The distances are going to be the same. So the distance of the express train is going to equal the distance of the freight train. So let's get all our equations written out and out of the way, and then we can start substituting. Every time when we have these equal distances, you're going to set, the first thing you want to do to get started is to set the distances equal each other. Another tricky part. That doesn't help us. There's no D's over here, is there? But we know that the distance equals rate times time. So the rate of the express train times the time of the express train equals the rate of the freight train times the time of the freight train. So I just took the distance and I expanded it so that we have the same variables that we have up here. We're going to do 3 examples, so I'm hoping by the final one that this starts making sense. So let's review. Draw the picture. Write down the things we know. We know the time of the express train, time of the freight train, and we know that the express train is, the rate is going to be faster than the rate of the freight train, so we have to add 15 onto the freight train to keep our equations balanced. Now it's just like what we did before. We're going to start substituting. We're going to take these rectangular boxes, within them, and substitute. So we know that the time at express train is 12. So I'm going to remember with multiplication, 2 times 3 is the same as 3 times 2, so I can switch the order here. And we have right here the rate of the express train is equal to the rate of the freight train plus 15. So this is the time right there. The rate of the express train is right here, equals the time of the freight train would be 16, and the rate of the freight train. One variable has to stay. You can't get rid of all your variables. So we have one variable, one equation. Now we just solve it. 12 rate of the freight train plus 12 times 15 is, get my calculator out, 12 times 15 is 180. 180 equals 16 rate of the freight train. Variables on one side, numbers on the other, so I'm going to subtract 12 rate of the freight train from here, and I'm going to subtract 12 rate of the freight train from here. And so I get 180 equals 4 rate of the freight train. Divide our 180 by 4, and we get 45. So the rate of the freight train is equal to 45, and it's going to be, what is it, kilometers? Kilometers per hour. That's rate of the freight train. And we know that the express train is faster. So we go up here, we have to add 15 onto that. So we get the rate of the express train is equal to 45 plus 15. So we get the rate of the express train equals 60. Make sure you get units on it, kilometers per hour. Whew. These are tough. But once you can understand how to set it up, I think you're going to find it pretty easy. And there's going to be a couple of you in class that say, this is simple, I got it without even doing algebra. That happens. But try to learn the method. let's go and again, I didn't fit everything in my boxes. All right, the members of the girls' club hiked to Lake Tenkiller at 2 miles per hour. Mr. Alley gave them a ride back at 12 miles per hour. Find their hiking time if it was 5 hours longer than their riding time. How far was it to Lake Tenkiller? Whew. Okay, first thing I told you to do is you have to do your diagram. I hope I left enough space here. So we have a distance. It's going to be equal distance. So the members of the girls hiked to Tenkiller. So here's the girls hiking. So we're going this way. They're hiking up the mountain. So this is the girls. We'll call this the hiking one. And then Mr. Alley gave them a ride home. So from here to here, they're coming this way. And we'll call that R for ride back. Now let's fill in the things we know. We know the distance of hiking equals the distance of riding, right? Same distance from there to back. And we can say the rate of hiking times the time of hiking equals the rate of riding, time of riding. So we know the distances are the same, and we know that distance equals rate times time. So that's why I was able to take the distance into the rate times time, and the distance of riding into its rate times time. So get that filled in. That's our main base equation that we're going to use. And let's find out what else we know. The members of the girls' club hiked to Lake Tenkiller at 2 miles per hour. So we know the rate. So we know the rate of hiking. So the rate of hiking was 2 miles per hour. We'll put the units in at the end. And when the rate coming home, the rate of riding was 12 miles per hour. So these are things we know. Now we have to set up our time. It said, let's see. Mr. Alley gave them, find their hiking time if it was 5 hours longer than their riding time. So the time hiking equals the time riding plus 5. The hiking time was longer, so we have to add 5 onto the riding time. So here we go. We have 1 equation, 2 equation, 3 equation, 4 equation. 1 variable, 2 variable, 3 variable, 4. So that makes sense. With 4 equations and 4 unknown. Now we just do a bunch of substitution. We should come out with the right answer. So rate of hiking was 2, so I'm going to put that in. Time of hiking was time of riding plus 5. Rate of riding is 12. Time of riding, that's going to be our variable that we don't know. So we just substitute it all in. So here we go. 2 time of riding plus 10 equals 12 time of riding. I'm going to subtract 2 time of riding from both sides, so I get 10 time of riding equals, whoops, no, that's just 10. 10, got carried away there, equals 10 time of riding. And if I divide both sides by 10, I get the time of riding is 1 hour. Let's see. And let's see our time of hiking. Let's get that in. That would be, time would be 1 plus 5 would be, time of hiking would be 6 hours. Now, we have to look back at the question. What are they asking for? How far was it to Lake Tenkiller? They don't want to know how long it took. They want to know how far it was. So we just have to take one of our distance formula. We know the distance, let's just do of hiking, equals rate of hiking times time of hiking. I'll probably pick the harder one. So rate of hiking, let's just find it. Rate of hiking is 2. And time of hiking is 6. So the distance is going to be 12 miles. And that's the question they want you to answer. So make sure that you answer what they're asking. So distance, we could have done the same thing. Distance of riding would have been 12 times 1, which would still give us 12 miles. All right, sorry this is so long, but it's really important stuff, and we have to take our time on it. All right, example 3. Durand drove to the oasis in 2 hours, and Medill walked to the oasis in 10 hours. How far is it to the oasis if Durant drove 16 miles per hour faster than Medill walked? Okay, same thing. You have to draw your pictures. All right? No one's above drawing pictures. So here we go. Distance. Distance. Durant drove. So this is Durant's distance. And Medill, he walked. But the distances are the same. Whoops. Medill. So distance of Durant equals the distance of Medill. So we set the distances equal, and we know that the rate times time is equal to the distance. And the rate times Medill times the time of Medill is his distance. So we have this is our main equation. Now we start writing things we know. Durant drove in 2 hours. So the time of Durant is 2. Time of Medill is 10. Here we go, our tricky rate stuff. Durant drove 16 miles faster than Medill walked. So the rate of Durant is equal to the rate of Medill plus 16. We have to add it on to the slower guy equal to faster guy. The book uses walked and drove. We're using the other way. We're using their names. Okay, now we have our 1, 2, 3, 4 equation and 1, 2, 3, 4 variables, so we're good to go. We're just going to start substituting. Rate. I'm going to switch these around and do my time first. Time, so it'll be 2. Time of Durant is 2. Rate of Durant is rate of Medill plus 16. And time of Medill is 10. And rate of Medill is that the only thing that we're going to keep as our variable. So we just leave that as n. And we're just going to multiply all this out, and hopefully we'll get the right answer. So we're going to get 2 rate of Medill plus 32 equals 10 rate of Medill. I'm going to subtract 2 from both sides, so I'm going to get 32 equals 8 rate of Medill. And we get 4, if I divide both sides by 8, get that, equals rate of Medill. So we got the first one. And remember, rate is, this one would be in, what are we talking about? Miles per hour. We want to know how far is it to the oasis. So we really don't even need to find Durant's rate. We just need to go and find, that the distance equals the rate of Medill times the time of Medill. We know his rate is 4. We know his time is 10. So if we multiply those two together, we're going to get distance equals 40 miles. So always look at what they're looking for. That's what they're looking for, is how far is it to the oasis. And also, just make sure you put your units on your final answer. You don't have to have your units on the part that's not your final answer, but it's a good habit. Alright, hopefully you got that. You're going to have to give it a try. Go back and look at the examples. You can look in the book if you want at how they did their examples, and we'll just see how you do. That's it for lesson 92.